In this video, I will show how to graph a parabola by analyzing the properties of the parabola and the equation. Keep in mind that you can always graph a parabola just by plotting 10 points, but eventually we do want to learn how to um, produce the same result um, analytically. So let's start. First of all, the question is asking to find the y-intercept, and to find the y-intercept, we set x equal to 0. In this case, setting x equal to 0 basically means we have to find y when x equals 0, and when x equals 0, y is equal to 6. So that's going to be the y-intercept. And as we're going through these steps, we can also start graphing the parabola. So y equals 6 means parabola will go through the point 0, 6. So this point will belong to the parabola. So we got 1 point. Find the x-intercepts if any. What does if any mean? If any means that parabola doesn't have to have x-intercepts. Parabola can completely avoid the x-axis. But to find them, if they do exist, we set y equal to 0. Setting y equal to 0 gives us the following quadratic equation. And now, to solve it, we have plenty of choices. We can solve it by factoring, by completing the square, or by using the quadratic formula. If you cannot factor it in 5 seconds, then I would suggest you using quadratic formula. In this case, however, factoring is pretty straightforward. It's just x minus actually factoring here is not straightforward, so I'm just going to use quadratic formula. X will be equal to 8 plus minus square root of 8 squared minus 4 times 6 divided by 2, and 8 squared is 64, 4 times 6 is 24, 64 minus 24 is 40, so 40 can be written as 4 times 10, so it's 8 plus minus 2 square root of 10 over 2, and we can simplify it as 4 plus minus square root of 2. Square root of 2 is a number close to 3, so the two x-intercepts that we get will be, first one is 4 minus square root of 10, which is roughly 1, and the second one will be 4 plus square root of 10, which is roughly 7. So it doesn't help us in terms of the accuracy of the graph, so I'm not going to plot these points yet. But once we start graphing, we will come back to this result and see if it makes sense. Now, how do we find the axis of symmetry of the parabola? Well, the axis of symmetry, what's the importance of this line is that, first of all, the vertex lives on the axis of symmetry. And second of all, if you know the axis of symmetry and you know a point on one of its side, you can reflect that point through the axis of symmetry on the other side. That could save you potentially some time. So to find the axis of symmetry of the parabola, there is a formula that says that the axis of symmetry will have the following equation. It will be negative b over 2a. What is negative b over 2a? These are the same coefficients that we used in solving that quadratic equation earlier by using quadratic formula. So basically the best way to remember this, negative b over 2a is just this part of the quadratic formula. So in our case, it will be 8 over 2, which is 4. So the axis of symmetry of the parabola is the line x equals 4. So it's this line. So this is my axis of symmetry, x equals 4. And next, we find the vertex of the parabola. finding the vertex of the parabola once you know the axis of symmetry is actually very easy, because we know the vertex belongs to the axis of symmetry. That means the vertex is the output of the parabola when the input is equal to 4. So to find the vertex, we simply replace 4 into the equation of the parabola. So 4 squared is 16, 16 minus 32 is negative 16, negative 16 plus 6 is negative 10. So the vertex therefore is 4, negative 10. So let's find negative 10. I would have to scroll down quite a bit to find the negative 10 here, but let me just change the scale. And let me redraw the axis of symmetry. So the axis of symmetry is at 4. The y-intercept was at 6. And negative 10 therefore will be 1, 2, 3, 4, 5. 1, 6, 7, 8, 9, 10. So this point for negative 10 is my vertex. Now, notice how the vertex is on the axis of symmetry. Also, we forgot to reflect the y-intercept to the axis of symmetry. So if you know that this is the y-intercept and you know this is the axis of symmetry, we know that there's got to be another point on the other side of the axis of symmetry. So y-intercept can be reflected. In addition to that, we can also now take a look at our x-intercepts. So one was somewhere around 1, and the other one was somewhere around 7. So 2, 3, 4, 5, 6, 7. So notice how they are also symmetric about the axis of symmetry. So these are the 4 points of the parabola that we obtained by analyzing the properties of the equation. Clearly, the parabola opens up here because the vertex is all the way at the bottom. And now to graph this parabola, all we have to do is just connect these points. So that's what the graph of the parabola looks like after we combine all the results obtained in this 1, 2, 3, 4, 5 steps. Now, again, let me remind you that the same results can be produced by just plugging in 10 different inputs and producing 10 different outputs and then plotting those ordered pairs.